Hello students, welcome to online physics classes. Today we are going to discuss about the new topic. That new topic name is motion in a plane. We completed the chapters. First one is physical world completed. Second one is motion in a straight line. Motion in a straight line we completed. In this session, we are going to discuss about the motion in a plane. First of all, we concentrate about the introduction. In previous chapter, we discussed about the concepts of position, displacement, velocity, and acceleration, and all these things are needed to describe the motion of an object along a straight line. We found the directional aspects of these quantities can be taken care by positive sign and negative sign. That means in motion in a straight line, we have only two directions. One is positive direction and another one is negative direction. That is positive sign and negative signs. That means in motion dimension only two possible directions are there. But in order to describe the motion of an object in two dimensions, that is in plane, or three dimensions, that is in space, we need to utilize a vectors. We need to describe a vectors to learn the language of the vectors. So, what is a vector? How to add, subtract, how to add the vectors, subtract vectors, and multiply the vectors. What is the result of multiplying of a vector by a real number? Whenever the vector is multiplying with a real number, what is the resultant value? All these questions we will learn in this vectors concept. Even along with that one, we are going to expand in the equations of motion in vector formation. My dear students, in your motion in straight line chapter, we never discuss about the vectors related. Simply, is it a vector quantity or scalar quantity we discuss, but we never discussed more depth of concept. But in the motion in a plane, compulsory we required vector concept. If you want to describe an object position or object motion, compulsory it requires a vectors chapter. That's why we are going to discuss the vector. Even based on these vectors, we are going to discuss the circular motion in our daily life. We will discuss about the equations of motions in vector formation, and we are extending the three dimensions also. From the motion in a plane to the three dimensions, we will extend these vectors concept. We will discuss about the what is a vector. What is a vector? If you want to understand the vector concept, now first you should know about the physical quantities. Physical quantities. What is the meaning of physical quantities? See here, my dear students, the quantities which are measurable things. All things are measurable. Those quantities are nothing but a physical quantities. Even we can tell it as the quantities that are measurable are called physical quantities. I will write the definition. See here, the quantities that are measurable are called physical quantities. Best examples are length, mass, time, velocity, acceleration, density, linear momentum, force, etc. All these things are physical quantities. Okay, physical quantities are mainly classified into three types. Next point is physical quantities are mainly classified classified into three types. Into three types. First one is scalar quantity, otherwise scalar quantities. Second one is vector quantities. Third one is tensor quantities. We will discuss all these things one by one. First, scalar quantities. What is the meaning of scalar quantities? See here, first one is scalar quantities. The physical quantities which have only magnitude, which have only magnitude and no direction are called scalar quantities. This is the definition. My dear students, all of you observe once again, the physical quantities which have only magnitude and no direction are called scalar quantities. That means it is having only magnitude. There is no specific direction. Okay. Next point is, in this scalar quantities, if you want to understand, it has some rules are there. It is obeying the rules. What are those rules? We will discuss right now. See here, a scalar quantity can be specified by a single number along with the proper unit. For this one, example is scalar quantity examples are mass, length, time, volume, density, work, pressure, etc. Even temperature also we can tell. Temperature also, etc. All these things. Some electric current also, one more example. Electric current. Okay. Next, to describe a scalar quantity, we require some specific points. What are those specific points? The specific unit of the quantity. First point is the specific unit of that quantity. B point is the number of times that unit is contained in that quantity. Okay. Based on these 2 points, I am going to explain one small example. What is the example is, a bag contains 100 kg of sugar, 100 kg of sugar. In this one, 100 kg of sugar is a scalar quantity. Okay, so here kg is the unit and 100 is the number of units. 100 is the number of units of sugar present in that bag. Present in the bag. Present in the bag. Okay. This is about the scalar quantity related point. Next one more point is there. One of the important point is that the scalar quantities can be added or multiplied, subtracted, and divided just as the ordinary numbers. That means scalar quantities are obeying the algebraic rules. Okay, the scalar quantities can be added, subtracted, multiplied, and divided just as the ordinary numbers. That means that is the scalar quantities are obeying the ordinary algebraic rules. That means the scalar quantities are obey ordinary algebra rules. Like for this one example is, if I am considering perimeter, otherwise sometimes they will take it as 2 kg plus 3 kg. 2 kg plus 3 kg, that implies 5 kg. Simply we can add it. This is one example. Second example is 3 meter into 4 meter. That implies 3 4s are 12 meters squared. Like this, these scalar numbers we can add, subtract, multiply. Normal ordinary algebraic rules. Okay, this is about the scalar quantity. Next one is vector quantity. What is the vector quantities? See here. Vector quantities. What are the vector quantities? The physical quantities which have the physical quantities which have both magnitude and direction and obey the laws of vector addition. What are the laws of vector addition? I will tell you. Don't worry. Are called vector quantities. are vectors. 4 are vectors. Okay, my dear students, my writing is not good. Please try to understand these points because this is writing on pen pad. Please try to cooperate. Maybe if my writing is not good, please try to understand when I am saying the sentence, my mouth, by using the mouth. Please try to understand it. For this one, this is about the definition, Anna. A vector quantity is specified by a number with a unit and its direction. With a unit and its direction. Okay. Even I said to you what is the laws of vector addition. See here, my dear students, laws of vector addition means, what are the laws means? Laws of vector addition means, there are 3 laws of vector addition. Which one we are going to discuss in this chapter? Don't worry. First one is parallelogram law of vector addition. Second one is triangle law of vector addition. Third one is polygon law vector addition. Okay, my dear students, whenever we are saying a physical quantity is a vector quantity, that vector quantity compulsory should obey these laws of vector addition. Then only that physical quantity is called it as vector quantity. Okay. Next point is, in this vector quantity, examples we need to discuss, later rules, something rules, all these points I will tell you. See here, for this one, examples are, displacement is a vector quantity. Displacement, velocity, acceleration, force, linear momentum, etc. All these things are laws of vector, that is a vector quantities. Next, these vector quantities cannot be added by using algebraic rules. One of the important point, these vector quantities cannot be added by using algebraic, now the algebraic rules you can tell it, by using normal algebraic rules. Compulsory, if you want to add the vector quantities by using these 3 laws only, we should add. Okay. Next point. To describe a vector quantity, we require to describe a vector quantity, we require. That means if any physical quantity is describing, it is a vector quantity. What are those important points? First point is the specific unit of that quantity. The specific unit of that quantity. Next, specific unit should be applicable, the number of times that unit is contained in the quantity. Same points we discussed in scalar quantity also. These two are the same points. One more point in vector quantity is the orientation of the quantity. Orientation of that quantity. What is the orientation of that quantity? Orientation means making angle. These 3 points should obey. Any physical quantity if any physical quantity is a vector quantity, compulsory that vector quantity, that otherwise the physical quantity should obey these 3 points. Okay, for this one example is a plane is flying from west to east. A plane is flying from west to east. West to east with a velocity of 50 meters per second. 50 meters per second. In this case, unit is the meters per second. Number of times, how many number of times it is repeated? 50 is the number of times present in the physical quantity. Present in that physical quantity. Particular physical quantity means here velocity. Particular physical quantity, velocity. Next, direction. East to west, otherwise west to east, they mention it. West to east is the direction, orientation of the direction. Direction, otherwise orientation. Okay, how to represent the vector quantity I will explain, don't worry about that one. So here a physical quantity having magnitude and direction but not obeying the laws of vector addition, then it can be treated as a scalar quantity. One more point, based on the vector quantity, it is one of the important point, a physical quantity having magnitude and direction, but not obeying laws of vector addition. What are the laws of vector addition? Please recall. Laws of vector addition means polygon law of vector addition, parallelogram law of vector addition, triangle law of vector addition. Laws of vector addition is treated as a scalar. For this one, best example is electric current. See here, electric current is a scalar quantity. Why? This current is a scalar quantity. Why? This electric current is a scalar quantity. Electric current, see here for this one explanation. Electric current is always associated with the direction. But it is not a vector quantity. but it is not a vector quantity. Why it is not a vector quantity? Please concentrate here. Because it does not obey law of vector addition. Law of vector addition. Law of vector addition. It does not obey law of vector addition. Now this one, which law it does not obey? Please consider this one. I am considering one current carrying conductor. This current carrying conductor is I1 and another current carrying conductor. This is I2. Both current carrying conductors are meeting at one junction point. From this junction, there is one more resultant of the current, that is I1 plus I2. That is I1 plus I2. It is the sum of the current I1 and current I2, but it is independent of the angle theta. And one more point, it does not obey triangular vector addition. It does not obey triangle law vector addition because sorry my dear students, I will explain this triangular vector addition in this chapter, then you can understand very clearly. Right now please try to observe that vector quantity. Here this electric current physical quantity does not obey the triangular vector addition. Okay. Next, the resultant of I1 and I2 is I1 plus I2 now. I1 plus I2. That means by Kirchhoff's current. By Kirchhoff's. We will discuss this Kirchhoff's in our second year intermediate. Kirchhoff's current law. Based on the Kirchhoff's current law. So the resultant does not depend on the angle between I1 and I2. Even whatever we got the resultant, the resultant does not depend on angle between currents I1 and I2. Angle between the currents I1 and I2 is independent of the angle, because in that resultant quantity, in that resultant dependent, is there any resultant theta term? No term. Okay. Next term. Now, one more point, that is a tensor quantity. All of you concentrate about the tensor quantity. What is the tensor quantity? See here, the physical quantities having different magnitude, different directions. Different magnitude in different directions. See here, the physical quantities having different magnitudes in different directions. These quantities are nothing but tensors, and these quantities, these physical quantities, do not obey the law of vector addition. See here, these do not obey laws of vector addition. Maybe you have a doubt. Sir, if these physical quantities, they do not obey laws of vector addition, so can we call it as scalar? Scalar quantities means only magnitude, but here we have different magnitudes and different directions. So we cannot call this scalars, but it is a tensor quantity. Okay, for this one, best examples are moment of inertia, stress, moment of inertia, stress, etc. We can tell it. All these are the tensor quantities. Now, we are going to discuss about the representation of vector quantity. Our next point is representation of vectors. See here, my dear students, how can we represent the vectors? All of you concentrate in this diagrammatic part. See here, a vector quantity is represented by a straight line with an arrow head over it. I will write the definition. See here, a vector quantity is represented by a straight line, with an arrowhead over it. Even representation of vector, we can tell it as it is a line segment. A vector can be represented by line segment, vector segment. We can tell it as. Even I am considering x-axis, y-axis based on the two-dimensional plane. I am taking the one vector. It is arrowhead, straight line with an arrowhead over it. This is arrowhead. O to A. With respect to horizontal, it is making angle is theta. Okay. So here O is the tail or initial point. What is the meaning of O? O meaning is the tail and toka. Tail or initial point. A meaning is the, this is Yena. This A meaning is the head or terminal points. Terminal point. The line segment. Vector can be represented by a line segment. Okay. This is the representation of vector. Sometimes the length of the line gives the magnitude and the arrowhead gives the direction. Whatever this is the definition, a vector quantity is represented by a straight line with an arrowhead. Means the length of the line gives the magnitude of, what is the one? The length of the line. The length of the line gives the magnitude, and the arrowhead gives the arrow mark అనేది మనకి డైరెక్షన్ రిప్రజెంట్ చేస్తుంది. Arrowhead gives the direction. Arrowhead gives the direction. Suppose sometimes I am representing in this way also. How I am representing? Suppose a body has a velocity 40 kilometers per hour due to east, I am saying. Due to east. How can we say east direction? That's why I drawn this diagram. Whenever we are drawing the directions position on a paper, in front of you there is a paper. On the paper, simply we can draw plus symbol. Simply you should draw plus symbol properly. After drawing that one, simply you should draw a plus symbol. After drawing that one, with respect to your facing, right side is east, you should represent it. Left side is west. Top position is north. Down position is south. You should write it. This one is north, south, east, west. Like this, you should represent it. Even sometimes some more better representation is there. Present basic representation you should remember like this. After completion of the representation of vector, compulsory I need to explain the this east to west different directions also. Don't worry about that one. I will explain it. Now, first you should focus on this base point. What they mentioned is the length of the line gives the magnitude and the arrowhead gives the direction. Arrowhead gives the direction means this is arrowhead, this arrowhead gives the direction. So I am giving one small example. Suppose a body has a velocity of 40 kilometers per hour. If you are considering due east means based on this one, I am drawing the vector representation. Vector representation. See here, this is east. This one is tail. This one is head. Tala toka. దీన్ని తల అంటారు, దీన్ని తోకగా రిప్రజెంట్ చేస్తారు. నేను తెలుగులో రాస్తున్నాను. ఎవరైనా తెలుగు మీడియం స్టూడెంట్స్ ఉంటే మీరు అబ్జర్వ్ చేసుకోండి. తెలుగులో మాట్లాడడానికి మీరే ఫీల్ కావాల్సిన అవసరం లేదు. జస్ట్ మీ అండర్స్టాండింగ్ కోసమే, ఫర్ ది సేక్ ఆఫ్ యువర్ అండర్స్టాండింగ్ ఓన్లీ ఐఎమ్ స్పీకింగ్ అండ్ ఐఎమ్ రైటింగ్ ద పాయింట్. Please concentrate this point. It is a very most important concept. In our entire physics, we are utilizing this vectors chapter. Please don't negligence on this chapter. Don't do any negligence on this chapter. So this total empties they given it is velocity value they didn't given. Velocity value they given. Velocity is equal to 40 kilometers per hour. Okay, due east, this is east based on the plus symbol. East, west, north, south. Based on the symbol, east direction. I am considering this is O, this is A. O is the tail, A is the head. If I am considering 1 centimeter, 1 centimeter represents a velocity of 10 kilometers. Suppose if I am representing 1 centimeter length, this from 0 to 1 centimeter length is 10 kilometers per hour. If I am writing a line OA, this entire line OA will be represented as this is 2 centimeters, 3 centimeters, and this one is 4 centimeters. Totally the length of the line, that is equal to OA. That OA is equal to 4 centimeters. In the length and the drawn towards the east with the arrowhead at A position, at A will completely represent the velocity of the body. It is representing the velocity of the body. So the point A is called a head or terminal point. Point A is called as head or terminal point. And point O, this is the point 1. Point O is called a tail or initial point. Tail or initial point we can take it. I hope all of you understood about this one. So this can be represented as in our textbook OA bar. OA bar. That is a vector OA also we can call. OA bar is equal to 4 centimeter east direction. Okay. This is about the representation of vector. Next point is to represent the vectors, we are using the bold letters. Bold letters in the textbook. Some textbooks bold letters, some textbooks they are writing the bar notations. Suppose if you want to write the velocity vector representation, velocity vector, how can we write it? The velocity vector can be represented by symbol. Bold letters means like this. Otherwise, some textbooks we can't write like this every time. That's why we are writing the like this vector V. Since both cases is difficult to produce when written by hand, if you want to write like this both face, it is difficult. That's why what they are doing is a arrow is placed arrow is placed over the head of the letter, that is say V bar. We can call it as V bar. So thus both bold letter and V bar represent the velocity vector. Represent the velocity vector. If you want to write like this in your paper, both place it is difficult. So in the place, if you are writing like this, it is also correct. Represent the velocity vector. Okay, my dear students, I hope all of you understood it. One more important point: the magnitude of vector is always a representing by the one of the important point. The magnitude of a vector is oftenly represented by, otherwise is represented by absolute value. Absolute value. In your mathematics, you have the meaning, absolute meaning. That absolute value means always, if you are representing velocity vector, modulus of V bar they are writing. This value is always a scalar form. That's why I am saying always the magnitude of vector is always a scalar. The magnitude of a vector is always a scalar. The magnitude of vector is always a scalar form. Okay, my dear students, the magnitude of vector is always a scalar. This is the magnitude of the vector. This value is a scalar form. This is representing it as a scalar form. Please try to recall the magnitude of vector is always represented by absolute value. That absolute value velocity vector can be represented like this. The magnitude of vector is always a scalar. If you are writing the modulus of V bar, that value will become positive. This value is always positive. It can never be a negative value. It can never be a negative value. Okay, my dear friends, I hope all of you understood this point also. Next, all of you concentrate about the different directions. How I am representing the directions. Please concentrate. If you are understanding this point, then you can able to understand, you can able to follow my physics concept. Okay, by drawing this diagram, I am not getting properly. That's why I will draw. See here how I am representing these vector directions are. Whenever we are drawing the plus symbol, this is east direction. This one is north. In between east and west direction, corner diagonal point is northeast. Even in Telugu, what they are calling it as ఈశాన్యం అంటారు. ఈ డైరెక్షన్స్ కంపల్సరిగా నేర్చుకోవాలి. ప్రతి ఒక్కళ్ళు నేర్చుకోవాలి. మనకి ఫిజిక్స్ లో చాలా ఉపయోగపడతాయి. నెక్స్ట్, దిస్ వన్ ఈస్ సౌత్. ద diagonal of east and south is southeast. దీన్ని ఆగ్నేయం అంటారు. The corner in between west and south is southwest. West south అని పిలుస్తారా? ఎవరు కదా? దీన్ని నైరుతి అంటారు. The diagonal of the west and the north is northwest. This northwest, in Telugu they are calling it as Vayuyam. Northwest is nothing but Vayuyam. Okay, తూర్పు, పడమర, ఉత్తరం, దక్షిణం ఇవంతా తెలుసు. సరే, మీ అండర్స్టాండింగ్ కోసం నేను రాస్తున్నానమ్మా. ఎవరైనా తెలుగులో తెలియకపోతే, తెలుగులో తెలిసిన వాళ్ళు ఉంటే మీరు కంపల్సరీగా గుర్తుపెట్టుకోండి. దీన్ని ఉత్తరం అంటారు, నార్త్ అని. సౌత్ అని దక్షిణం అంటారు. Okay, these are the directions. Please remember it. Next, we are going to discuss about the types of vectors. In this types of vectors, first vector is equal vectors. equal vectors. First vector is equal vectors. See here, in this word we have the meaning equal. Equal. That means two vectors are said to be equal if they have the same magnitude and same direction. I will write the definition. Two vectors are said to be equal if they have the same magnitude and the same direction. Same magnitude and the same direction. In this case, I am representing this is the definition, same magnitude, same direction, then we can call it as equal vectors. I am considering the two vectors, that is, one is vector A and another one is vector B. These two vectors having their magnitude remains same. That means the length of the vectors remains same. Magnitude is same and the direction is also same. So these two are called the two equal vectors. Two equal vectors. My dear students, wherever simple equations, simple definitions, please try to remember it. Next, second one is negative vector. Negative vector. See here, negative vector means the negative of a vector is defined as another vector having in the same magnitude. All of you observe the definition. The negative of a vector is defined as another vector having the same magnitude, but having an opposite direction. Having an opposite direction. This is about the negative vector. So, my dear students, please concentrate here. If I am giving you one small example, I am considering a vector A. I am considering vector A. This vector A is having a certain amount of magnitude and direction, specific direction. But I am drawing the another vector is this direction, but B bar is equal to minus A bar. Magnitude wise remains same, but the direction wise is both are different. So vector A is the negative of vector B. Vector A is the negative of vector B bar, or vice versa also. Vice versa. This is about the negative of a vector. Okay, my dear students, one more important point, please concentrate. Third one is modulus of a vector. Modulus of a vector. What is the modulus of a vector? See here, already explained, magnitude of the vector is always representing by absolute value of the vector. That means modulus of vector. See here, the modulus of a vector. The modulus of a vector means the length over the magnitude of that vector. The magnitude of that vector It is also a scalar quantity. It is a scalar quantity. This is the definition of modulus of a vector. So modulus of vector can be written as modulus of vector A is equal to modulus of A, modulus symbols, that is equal to A. This is a scalar. Okay, I hope all of you understood about this modulus of vector. Modulus of vector is the length or magnitude of the vector. Next, last and final vector in this session. Some more different types of unit vectors, some more different types of vectors are there. I will explain all those vectors in my next class. One of the important vector is unit vector. My dear students, in these types of vector, they have a chance to ask 2 marks question also. Even this one is 2 marks question for IP level. Not all IP level. This one is very most important for our mains level concept. Unit vector. See here, a unit vector is a vector of unit magnitude. Unit magnitude drawn in the direction of a given vector. It is, maybe you will feel some difficulty this definition. So I will tell you this definition is a very easy way. What is that definition? Is a vector having magnitude is unit. A vector having magnitude is unit. Otherwise, my dear students, please don't follow this definition. Maybe you will feel some difficulty. I will tell one of the simple definition. This one also you can write. A vector whose magnitude equals 1 and used to specify a convenient direction. Direction is called, that means a vector whose magnitude is equal to 1 and it is used to specify a specific direction is called a unit vector. Okay, my dear students, please remember it. A vector whose magnitude equals to 1. A vector whose magnitude is equals to 1 and it is used to specify a convenient direction. That's why this vector is nothing but unit vector. Please consider this unit vector. Some of the concept is there. This unit vector can be representing by a cap. Even a unit vector, this unit vector has no units and no dimensions. One of the important point, a unit vector has no units and dimensions. Its purpose is to specify a direction of a given vector. What is the main purpose of unit vector? Its purpose is to specify the direction of given vector. Okay, even this vector can be representing by a cap. So this formula is a cap is equal to a bar divided by modulus of a bar. See here, my dear students, vector A divided by This modulus of vector A is always scalar, na? That's why A. So simply we can write as vector A is equal to A into A cap. My dear students, it is one of the important formula. Please remember it. Based on this unit vector, I need to explain more depth. I will explain in my next class that depth of point. So here I am going to closing this session, my dear students. Thank you.